Okay, so I want to go over this problem involving inverse trig functions. So given something like this, and then let's say we're asked to find the exact value of this expression, all right? So we'll start off looking at the tangent inverse. So let's say that, so remember what an inverse function represents, right? When we have a statement like tangent inverse of 5 over 12, right? The output of this is some angle. So I'm just going to call it, let's say, theta. All right. And properties of inverse functions will tell me that, well, that means that tangent of theta is equal to 5 over 12. All right. Now, if we set up our triangle here to see, all right, so it's in the first quadrant, right? It's positive. All right, and the domain of the inverse tangent is from negative pi over 2 to pi over 2. Right, so if it's in the first quadrant here, so we have the opposite is 5, and the adjacent is 12 for this angle theta. All right, and we can find our side C using the Pythagorean identity, where we have c squared is equal to 5 squared plus 12 squared. Simplifying this, we'll come up with the result c is equal to 13. All right. Okay, so now let's take a look at the sine inverse. Right. So for the sine inverse of negative 8 over 17. Again, remember, right, the output of an inverse function is an angle. So let's call this angle beta. Right? And through properties of inverse functions, we have sine of beta is going to be equal to negative 8 over 17. All right. Now here we have a negative value for the sine of beta. Right. So that tells me that it's either in quadrant 3 or in quadrant 4. Right. Now which one do I choose? There I go back and look at, all right, what is the domain of the inverse sine? And the domain comes from negative pi over 2 to pi over 2. So the angle beta has to be this angle here. All right, so it is in our fourth quadrant, but it's measured in the negative direction from the standard position there. All right, and from here we have this value to be negative 8, and this value here is 17 for the hypotenuse of our triangle there. All right, now to find this other side, again, we'll use our Pythagorean identity, where we have 17 squared. I'll call this side a squared plus negative 8 squared. All right, and then simplifying all this, we get a is equal to 15. Okay, so now let's go back to our original expression, the one we wanted to evaluate. All right, and what it comes down to is I want to evaluate here, cosine. All right, tangent inverse of 5 over 12, which I said I was going to call theta. Sine inverse of negative 8 over 17, which I called beta. So we would like to evaluate the expression cosine of theta minus beta. All right, so at this point, let's use an identity. All right, so I know that the difference identity for the cosine is cosine theta cosine beta minus sine theta sine beta. All right. Remember, it is not cosine of theta minus cosine of beta, right? The trig functions are not what we call linear. They don't follow that same kind of pattern, right? That this expression is equivalent to what we have here on the right side of the equation. And then from here, we just look at our triangles and we just figure out what these values are. All right, if I look at cosine of theta, well, cosine of theta will just be, excuse me, 12 over 13. right? Adjacent over the hypotenuse. Cosine of beta, right? Looking at our beta there would be the adjacent, which in this case is 15 over 17. All right, and then from here, the sine of theta, right? Looking at that, we have sine of theta is 5 over 13. And then sine of beta, here we have negative 8 over 17. Okay. And now it just comes down to simplifying. So 17 times 13 is 221. And here we have 15 times 12. We have 180. And then plus 5 times 8, which is 40. So here we have 220 over 221. And that would be the exact value of my original expression. All right, and that is how you evaluate these inverse, this composition of inverse trig functions with a trig function self. Thank you.